Well, we're now in Chapter 2 in Section 1. And we just finished Section 2.0, which was actually before Chapter 2 in your book. And we reviewed the Math 341 principles to make sure we were really familiar with linear algebra and how you do echelon form and get your solution and so forth. But one thing I want you to remember as we went through 2.0 is we had a lot of freedom. We could do elementary row operations in any order we wanted. No problem. As long as we didn't make any mistakes, you'd always end up with the same result. And that mathematically is always true. But we are not going to be quite so liberal in Section 2.1 and 2.2, in fact, the rest of Chapter 2. The reason for that is we are going to be strategic about which of those elementary row operations we want to use and when, in order to try to gain numerical stability as well as efficiency, both in terms of memory and in computation speed. So we're not going to be quite as generous here. We're going to be strategic, however. Okay, so let's go ahead and take a look at the problem statement. It's revised a little bit from your lecture notes, but it's really the same basic problem. I do want you to review the P code through this entire section, Section 2.1. You're going to be copying it, basically, turning the pseudocode into MATLAB programs. And this is the first step in problem 1, and that is to load a matrix that I'm calling A and a vector I'm calling B from the Excel files I've supplied. Now, I've supplied 3 of them. One is called A, one is called A2, and one is called A3. For right now, in Section 2.1, we're only going to be using the A file. Now, I will give you in the hint section very soon, I'll give you the code that's required to load an Excel file into MATLAB and to pull out the A matrix and the B vectors separately. So you'll be doing that, but that's a giveaway. Then, what isn't a giveaway is to triangularize matrix A in place. In place means that you don't create any new vectors, you don't create any new matrices at all. You must use the matrix A that came out of the Excel file and the vector B, and you can use extra variables. You can use integer variables and real variables, but no new arrays. You must use the space provided in matrix A and in vector B. Okay? And then finally in 1C, you're going to be carrying along vector B in place in such a manner that you're going to solve the equation AX equals B. Now, the way we would have done it in Section 2 is you would have literally taken vector B and augmented it to the right of matrix A, making it having one additional column on the right. You're not going to do that here. You have to leave A alone and you leave B alone, but both A and B will change as you work through the elementary row operations. So that takes care of 10 points on problem 1. On problem 2, I want you to write your own script to find the rank of A. You may not use any MATLAB supplied code. You can do all these things in MATLAB, but we don't learn anything, so I want you to write it yourself. I'll be giving you help, a lot of help on the hints file. As far as 3 is concerned, you'll then use back substitution to find the solution itself, and the result will go into a new vector X. I told you couldn't create any new vectors. Here's an exception. You are allowed to allocate space for a solution vector X after you're ready to do back substitution. Item 4 is you must print these out. So when you print them out in MATLAB, but capture that somehow from your screen or from a file and include it on your PDF file. I actually want you to give me your results so I can look at them and compare them to mine and don't have to run your program to compare it. So the things you should be printing is your triangular matrix, or your triangularized matrix A, and the modified vector B. Obviously it has to be changed. So print out the matrix and the vector. Print out the rank and the solution vector X, so it's very clear. And then finally on 5, you need to keep track of flops. Remember, flops stands for floating point operations. I want you to count every time you do an addition or a subtraction, multiplication, division, and those all count as flops. But don't count integer increments, like if you're building an index to try to keep track of where you are in a matrix, like matrix A or vector B. Don't count integer operations, only count floating point operations. So there you go. That is the homework you have to do. And now for hints, I've given you some really significant hints here. First of all, here is the exact code you need to import the Excel file called A. Once you run the import file, now this is going right on your MATLAB file, so this is not a special program, this is just the first few lines of the MATLAB program you're building. So you read in or import in the A file, and then lines 2 and 3 there allow you to extract the A matrix and the B vector very easily, as you've seen it there. Do find out what the size is of matrix A. I've said M and N there, but it better be square because you're going to be solving this thing. And then initialize your flops variable to 0 before you do anything else. Okay, so that is the initial part of the homework submission that you'll be having. And everything else you need to do goes directly below these lines of code that you're looking at. Okay, and here is the rest of it. Very, very strong hints for you. You're supposed to triangularize matrix A, that's problem 1B, and 1C is making sure you do this so the computations are done in place and you're not adding or modifying or creating new vectors like B or creating a new matrix like A. You're just leaving them the way they are and changing the values in those two structures. Okay, now I have given you the MATLAB code, even with comments, even with the indenting that I keep insisting on, to do the triangularization. It's all there. In fact, if you look at the pseudocode in the book, you'll see that it agrees with it in structure. The only thing I've done is replaced real variables there with ZZ. Think of the ZZ as like a blank, and you just need to fill in the blank, okay? And don't think that the ZZs are all the same thing, because they're definitely not. Okay, there's your triangularization code given to you on a silver platter. Here's the rank code that you would do next. Right after you finish triangularizing your matrix, you can come up with a rank. And even though there's a big blank line right here, that's just to give me space to get more comments in. So there really shouldn't be anything there. And that will then give you the rank. Okay, and then finally, you need to do back substitution. Keep in mind, we are not trying to do echelon form. We're not doing reduced echelon form. So your diagonals are not necessarily ones. And the back substitution code will account for that. So just like before, we have a lot of code structure here. And every time you have a ZZ, then you need to figure out what ought to go in there. And that's basically your homework. Oh, don't forget to add the flops counter. You're going to embed flops counters everywhere that you create a floating point operation. So make sure you put that in there that is accurate, that you get the right number of floating point operations. Okay, so from that, really, you should be able to do the homework. And this is critically important to get right. The reason for that is in section 2.2, we're going to have 4 separate homeworks that go 2.2 A, B, C, and D, and every one of them relates back to this code here on 2.1 or a revision of this code. So you really have to get this right, make sure this thing works to be able to get 2.2. Okay, so give it a shot and we'll come back and look at the solution.